In this lecture, we're going to learn how to forecast seasonality through regression analysis. What we have here is the data for milk demand in a milk farm in India in the Madurai area. The first thing that we want to see is to take a look at how does the demand look like. And so we're going to select the data from April 2008 through March 2011 that we've been given. And we are going to insert a scatter plot with lines. And this is how the demand for milk looks like for that farm. We see some peaks and valleys, ups and downs. And if we look carefully, the highest peak on each month is October, every single time. So you can see how it reads there, October, the label. And this coincides with the Diwali festivity, in which families get together and they cook a lot of desserts that require a lot of milk. So this is one of the reasons why the demand peaks on that month. And then it happens again in December, and then it reaches the lowest point, which is typically February of every single year. And so what we want to achieve now is to be able to forecast both the growth, because it's difficult to see, but there is some growth in the demand of milk overall. And we could look at that by adding the trend line as usual. And there it is. We can see how the yearly average of the demand of milk is going up. If we just use the linear regression, this is what we would obtain. We would get rid of all of the peaks and ups, and we wouldn't be able to accurately forecast. And this is critical because we need to plan resources in advance, and inventory and cash flow, when we know we're going to have the high peaks to be able to satisfy the demand. And we also need to be prepared to maybe slow down the production, probably cut down on overtime, and sometimes even make layoff decisions when we have the low valleys, because at this stage our demand is so low that maybe we need to incur in less fixed costs to be able to remain profitable. I'm going to get rid of the chart for now. Later we'll come back to it. And what we're going to be doing now is we will use, so this is the y, this is the variable we're trying to predict. And in this time, I'm not going to use period as the x as we've been doing before. Instead, we're going to use year. And what we're going to say is that it's important that Excel understands that all of these data points belong to the year 2008, and that this one's to 2009, and then 2010, and so on, because that will help us to catch on the trend that so far the demand for milk has been constantly increasing. Now the question is, how do we help Excel to understand that these months are particularly high, Octobers on each year, here's the other one, are October precisely, and how do we help Excel to understand that these values that are quite low on every year corresponds to February? As we know, we cannot input into Excel text. However, we can input dummy variables, and that's exactly what we're going to be doing. We're going to create a dummy variable for each of the months, except for one of them, and we're going to be able for Excel to identify which months are which. So let's select from April through February, and notice how I'm not selecting March on purpose, because if you remember from our class, in order to create dummy variables, we need one less variable than the number of options. So there are 12 months or 12 options for a month, so we only need 11 variables. So let's select from April through February, and I'm going to paste it here with the transpose function, either here or for the PC, checking the box paste special and checking the box for transpose. And I'm going to reduce this in width so we can see it all in one go. Here we go. And then we need to code the variables, which is extremely easy. We're going to go through the diagonal to indicate the ones of which months that this is February, this is January, and so on. And then for the rest, we need zeros. So what we do is we put 1 0, and then we copy it, and we select all of our matrix, March included, because we need March. March is going to be all zeros. I'm going to explain in a second why. So I copied, I selected everywhere, and then we go to the menu, Edit, go to Special, Blanks, and click OK. And now Excel has selected everything except the ones, and then we paste the zeros. So in a couple of seconds, we have now coded all of our dummy variables. Now, why is March making all zero? Because what we're saying is this month is not April, it's not May, it's not June, and so on. It's not January, it's not February. So the only option is that it's March, because it's not none of the previous ones. Now that this is on, we just copy the months 2 times, the dummy variables, and now they all match nicely. If you had a way larger database, you could just select all of the rest of the data, and as long as you have the same months in the same order, it will be very easy just for you to paste. Now we're ready to run the regression. Let's go to StatPlus, Statistics, Regression, Linear Regression, and my dependent variable is the demand of milk, and the independent variables are the year and the months. And let's run the regression. And here are our results. I'm gonna pause the video for a second to be able to clean the screen a little bit. Alright, so I have just cleaned the screen to keep what is important. I'm gonna get rid of the equation too. And this also looks a bit closer to the ones to the output in the PC. Now, as usual, the first thing I want to look at is at the adjusted R-square, and we're getting 91.9%, which is quite high. It means that just by knowing the name of the year and the month, we are able to explain 92% of the demand of milk, and that's quite high. So as we just learned in the Kodak case, unless something dramatically changes in the milk industry in the Madurai area, we should be okay to continue using this model to predict the future sales or demand for milk. The next thing that we will look at is at the p-value. In this example, the only variable that is not statistically significant would be February. And it actually makes sense because it was the lowest variable. So this is the variable that is being affected the most by the peaks and valleys. So typically the ones that are very extreme could be having a non-significant p-level. However, the good thing here is that we are getting a negative number for February, and Excel is telling us that the confidence interval does include 0 as part of the interval, so it could go either way, which means that in some years the drop has not been as high as in other months, or in one particular year there was a February that was particularly low, and that is pulling the average towards the left. In this case, just as usual, I'm gonna make the call to keep it because yes, the p-value is not extremely promising. However, it is giving me the right sign, which means that I should be subtracting, whenever it's February, I should be subtracting some demand from the average milk that I usually sell. This call again depends. For example, if I would have gotten February a higher number that I need to add something, and with a high p-value, then I would have deleted it because I know that that is not accurate. I want February to be the lowest. So it makes sense that this is the lowest value for February. Then take a look at October, and October has the highest coefficient, which means that whenever it's October, we need to add another 4.1 million liters of demand of milk versus the average for the year. And so in general, we could create here a heat map to give us an idea of the peaks and valleys, and this has to match very closely to the peaks that we saw earlier. So we knew December was a high month, we knew that January and February were not so good, and then we didn't go through them, but if we go back to the previous chart, we will see that indeed May, June, and July are again high months, and that corresponds to the Holy festivity, another festivity in the area. Now we need to use these coefficients and the year to predict the sales. So this may seem a little bit daunting, but we already have the coding for our variables in dummy. So I'm gonna go back to the original file. We're gonna repeat what we used to do earlier, which is, let's pull down a couple of months here. So let's say that I want to predict one more year. So what I would need to do is to predict from April through March of the next year. And so this will become 2011 again until December. And then we would jump into the next calendar year, but still within the same fiscal year for the company. As usual, I don't need the period because, this time I don't need the period because we're not using it. What we need is the dummy variables. So all I need to do is to copy them one more time from our previous generation of the dummy variables. And now, let's bring these values to the same sheet where we have the regression. I will paste them here. And next, I'm gonna open one more column here so we can have, there we go. So we can have the word forecast, and this is where we're gonna produce the forecast for milk. Now, what do we do with these dummy variables, and how do we match them with the coefficient? Well, the way this works is, every time that we know that it's July, we are gonna have to add 2.8. Every time that we know that it's September, we're gonna have to add 1.9. Every time that we know that it's November, we're gonna have to add 2.2, and so on. So these variables only count one time per year when we have that particular month. But that's exactly what we have in the dummy variables. We know that for April, we should only be counting the coefficient of April and none of the other ones. We know that in September, the only coefficient that we should have is September, and here the rest tells us that we should not be using it, which are the zeros. So there is a very useful function called sum product, which is going to help us to achieve that. I'm going to take the coefficients from April to through February, and I'm going to paste it here. And I'm going to do values so that I don't bring the formatting, and transpose. And now I have the numbers towards the right. I know you cannot read them because they're quite large, but they are exactly the same. So all I'm doing, look, I have here the 1.6623 is this one. This is 2.85. So just bear with me. Let me close them a bit so that we can see all of the variables, and then at the end I will open them again to show you what the end result looks like. So now that I have everything here in one screen, let's generate the forecast for April. The forecast for April is going to be given by the coefficient and the intercept, and I'm going to fix that column because it will always be the same regardless if I move my formula down, plus the year that I'm forecasting, which in this case is 2012, times the coefficient for year, and we fix that column with Command T or F4, plus we're going to use the sum product of these coefficients, which are the same that the regression equation gave us. It's just that now I have copy-pasted them in values and transposed, and we fix that, times the dummy variable. And I will tell you why this is exactly what we're doing. So this is the answer, and I'm just going to format this nicely so that we can read later on. No decimal places. So the forecast for April 2011 is 9.7 million liters of milk. And now I can pull this formula down, including March, and you'll see in a second why. And now we have generated the forecast for all of these months. The building of this equation is exactly the same. Nothing has changed. We need the intercept, then the coefficient times the value. The only piece that is kind of new are the use of the dummy variables. I think it will become very explicit if I'm able to show you what does the sum product function is doing. So let me format this one more time. So that I'm gonna try my best to make it show in one section. So let's pay attention to what the sum product is doing. Sum product, what I said is, let's select the coefficients, and I fix that, comma, the dummy variables values. And if you pay close attention, let me format it. Do you see how the numbers match? So this is 1,623,000 and this is 1,623,000. 2,851,000 and 2,181,000. This one over here is 4,146,000, 4,146,000. So what the sum product is doing is taking 1 times 1 million plus 0 times this plus 0 times this, and any number multiplied by 0 becomes 0. So what sum product is really doing is just adding wherever it found a 1. And what this means is that whatever the regression equation gave us, we need to add the extra amount of milk that is being consumed or demanded in the Madurai area. And this is why the sum product function works in a very efficient and fast way. Now that we're done, I'm going to take my forecast here and I'm going to bring it back into the original sheet that we had. Let's paste it as values. Let's format the tag here too. And lastly, we're going to continue pulling this formula down, the one that builds the dates. And I'm doing this because I want to show you how, through regression, we have been able to generate. Let's create it. Here we go. We created now a forecast, which is the last 12 observations. And these 12 observations have both the linear trend that we saw earlier, that year on year on year we're selling more milk, and also we have the peaks and valleys that match exactly the months that we're supposed to be seeing. For example, this peak over here corresponds to October, this is December, and then our lowest month is February, which matches exactly what we expected. So through the use of dummy variables, we were using the tool Regression that by now you should have mastered, and we were able to produce forecasts that have both seasonality and trend.